All right, welcome everyone. We're going to talk to you today about bringing some ALM into the cloud. And my name is Mick Kirsten. I'm the CEO of PaaS Technologies and the creator of the Eclipse ALM project. I'm joined by Gangadhar Kunduri from Oracle, who you might have seen in this morning's keynote with Thomas Kurian, and Lucas Bander, who's the development lead for the open source components here from Taskstop. So what you'll see a lot of in sort of all the developer conferences that you go to, and especially Oracle World Java 1, is the transformation that we're seeing on the application development side with the cloud. So we've got both in terms of maybe what you saw in the earlier keynote this morning, how infrastructure as a service is now established. On top of that, there's a lot of the innovation and a lot of the change that's driving the way that we build application is on the next layer up, on platform as a service. So that the applications that we're actually building, they're these very much service-based hosted applications. That's becoming easier, much easier in the economy of scale, and the hosting supports that. And now all of that is becoming available for Java, which is a really big deal. On those layers, we've got some, these currencies of virtual machines, then ready-made services and app hosting. That's transforming the way that we build applications. But what often takes a back seat is the way those applications evolve over time. So not only the way that we build the application, the way that we deploy them, and the change from the deployment destination being under our desk to being in a data center to being a hosted destination. The way that that application evolves over time, the way that we go from requirements, the way that we collaborate with our team members, the way that we spin up new projects. And so just like there's been a lot of innovation on the application development side, the application lifecycle management side is changing, and these two things need to change together. They need to evolve together. So in this talk, we'll take a look at that ALM angle of this move to cloud, and really addressing not just where the developers deploy to, but the way that we work day to day, and the way that this is affecting our tool chains, and the way that this provides us with a lot of new opportunity, and how we can plug this into the Oracle Developer Cloud Services. So a really interesting change in the way in application lifecycle management over the last 10 years has been just how much developers have transformed the ALM stack. So it used to be that large-scale applications were managed with tools like ClearQuest and ClearCase and the Rational Unified Process. These very stringent management-centric processes that were very rigid. And then, basically agile development and these very lightweight open source tools transformed everything. So things that were very much driven and architected around managerial control have been disrupted by things that support developer control and ease. And these tools that became popular, so Bugzilla was one of the main innovations. There's some tools before it. Tools like Jira actually just take that same model of Bugzilla. Zilla in Japanese you pronounce Jira, and that's where the term Jira comes from, is Bugjira. By the way, Japanese people actually pronounce Bugzilla. It's that same mental model of very lightweight workflows that's been commercialized in a lot of these tools that we also have open source tools for. Source code, as we moved from CVS to Subversion, Subversion was a big disruption, and now Git. Tools like Mercurial as well. So these are just some examples biased to the Eclipse ecosystem. And in this Eclipse community survey, the numbers are similar from last year's Eclipse community survey. You'll note that for organizations not just contributing to Eclipse, but using Eclipse, the open source tools have the majority of the market share. These very lightweight tools have the majority of the market share. So a lot of new projects are ramping up with tool chains like this one. And there's been evolution, right? Cruise control is almost out of the stack, of most people's stacks. But there's been this disruption because these tools make it very easy for developers to work. They're, all the sorts of planning and managerial facilities and ways of doing sort of traceability across the life cycle, they're actually missing from these tools. These are just very lightweight tools that make developers very productive. There's this problem because the burden on setting up these tools and these tool chains has actually now fallen on the developer. You've got your IDE, you've got your ALM server, so you might have set up your Garrett and your Git, and you're trying to figure out the best practices and how to wire things together. You're setting up your IDE manually all the way as well. So you're now connecting to 6 different servers from your IDE and trying to, the passwords for each one and setting up the configuration for each one and figuring out which Hudson jobs you care about for this release because there's 300 of them. And then you've got your application, which you have to connect to. So your application is whether it's hosted or whether it's, it's on premise, there's a lot of setup that you have to do to get the right branches for the application to do that. So there's just a ton of this manual work because the tools are disconnected. So with Oracle, we saw this interesting opportunity of using the new hosted development destination, taking some of the best of breed aspects of these open source tools and putting together this interesting offering for developers. So Gangadhar is going to show you some of this new offering that he summarized this morning. And I'll show you how it plays in with these open source components and this integration layer that we've been working on.
Excellent. Thanks, Mick. How many of you were at the Thomas Kurian keynote this morning about the Oracle Cloud? Not many of you, so I can repeat the whole thing. So one of the things that Mick was just talking about is I need to do all of this setup to start a development project, all the tooling that I need. And in the end, if what I'm going to produce is an application that is going to run on the cloud, the obvious question is, why can't I have all this setup in the cloud? Why can't I have this all integrated with the runtime that is going to be in the cloud? Why can't I have a developer cloud? And that's the Oracle Developer Cloud Service. So it provides a turnkey development environment that you can go to cloud.oracle.com and sign up, and you get a complete development environment, including the basic functionality with source control, tasks, Wiki, continuous integration via Hudson, and automatic deployment to the Oracle Java Cloud Service and the Oracle Database Cloud Service. So you can do continuous integration deployment into the cloud as well. And this is all integrated with the rest of the cloud. There are collaboration tools, and it is based on the same set of standards that you're already familiar with. Source control via Git. You can also use GitHub if you don't want to migrate the code to start with. There is issue tracking functionality built in with flexibility so that your issue, you can track bugs, you can track tasks, you can track enhancements with flexible searching, tagging, and all the functionality that comes with issue tracking. Continuous integration via Hudson. And then Wiki for project planning. And then collaboration via all these subsystems publishing into activity streams so that your distributed development team can collaborate with each other via these notifications that come through activity stream and email, etc., etc. Also that while Developers Cloud Service takes care of setting up all the environment and all the key functionality that is needed in the cloud, so that you, as a developer, can focus on what needs to be done for the business logic of your application. Commit your source code, track and monitor if the builds are going through fine, and then deploy the application to the runtime, and then test your app. The Developer Cloud Service provides multiple interfaces. So you can obviously use the Developer Cloud Dashboard, which we're going to demonstrate in a few minutes. You can also pick your favorite IDE. It's all integrated with all these three IDEs, JDeveloper, Eclipse, NetBeans. You can work on your tasks from the IDE. You can work on your source control and push it to the cloud using the IDE. You can test the application using the IDE, all of that stuff. You also have SSH access to Git. We also expose REST interfaces so that you can build custom tooling on top of it. And as we'll demonstrate later on and talk about it, there are partner applications like the Task Sync that demonstrate that capability. And, well, we have the founder of the Mylin project here, so obviously Mylin is all integrated with the Developer Cloud Service. So with that,
thank you. So what we're doing here is taking all of those things, and again, the key goal here is you just get a turnkey offering. You're getting some of the best of breed open source tools for basically, working with your code, working with your issues, doing code reviews and the like. And if this is all seamlessly hooked up into your project hosting, and then the key thing is that you'll see at the end, into your deployment destination. So the components that you'll see is we'll do a longer demo and walk you through this. The components that you'll see here, we just saw, so there's Mylin, Hudson, Git, Garrett, and then this turnkey offering and automation and hosting and framework on top of it, with this goal of getting you, everything that you need for enterprise scale Java development with all the benefits that you want from lightweight open source code hosting. So this is the robustness of an enterprise cloud with the lightweight tool set that has evolved in open source. The scalability, so you can host as many projects as you want, with the sort of transparency, which has been the working model and the success of those tools like Jira and Track and Mantis and Jira, all captured in here. And so that your teams have that velocity of these high efficiency tools, but you can also layer in, as you'll see at the end, potentially your own planning tools, which you might have on premise with some of the integrations that we're layering on top of this. So with that, we'll switch to Lucas doing a demo, and then we'll talk through some of the features and just give you an overview of the Oracle Cloud Developer Service.
Cool. Okay, so we're going to do a demo partially of the Web UI, and then we're going to look at the Eclipse tooling as well to show off all the automation and how to connect all these services. So the main way to access the Developer Cloud Service is through this website. So this is your main landing page once you've logged in. You can see all the projects you have access to. There are various levels of access to each project. They can be private, just to you and the team members you've added, or they can be shared within your organization. Creating a project is an extremely lightweight affair. You need a name, an optional description. You choose this privacy setting, and you create the project.
So if you've set up your own instances of these projects before, this part, at least the first time it happens, the second time you'll take it for granted. The first time is kind of like magic. All of those servers and services were just provisioned for you completely transparently. A Hudson instance where you can add your build jobs and issue tracking, the source code repositories with Git and so on, Wiki and such, all of those things that Gangadhar mentioned. So all of that is now exists for your project. And it's almost instant provisioning.
So I've just created a new project, and now I want to add someone to my team. So in the Oracle Cloud, you've got your identity domain for your organization once you've signed up. And I know that Gangadhar's in my domain, so I can just add him to my project. And I can set the role I want to give him. So he now has access to the project. He's got full access to do whatever he wants within the project.
So it's the same identity domain that all the rest of the cloud services in Oracle Cloud are connected to, Lucas, so that we can share users and permissions and other details between the cloud services?
Absolutely.
And that's another thing that's interesting, right? If you've set up Git, it's got a completely different access control model. So all of that has been layered in to these tools. Again, it's just completely turnkey for setting up the project, everything working, and the identity being delegated to your Oracle identity.
I'm just going to switch to a project I created yesterday that has a little bit of activity. So once you've got a project set up, every project has its own homepage, a short description about the project that you've created, a stream of the latest activity within the project, and then pointers to some of the associated services so that if you're using some tools natively, you have the URLs readily here for you. So these are 2 Git repositories within this project. Second, every project has its own dashboard. So you can see all the builds that are configured for this project. If I'd done any commits recently, we would see a graph of commit history and then history of tasks. So a small chart showing how many open tasks, closed tasks, and commits over time. And again, a longer version of that activity stream. So here it looks like I created a task. So let's just go to that task. So you get a full-featured built-in open source task system. It's based on a Bugzilla-compatible schema. So if you've got any data in that format, it's easy to get in here. But it's an all-new web UI built with GWT. So it's fast, it's responsive, but it does all the things you'd expect a bug tracker to do. So I can come in here and say, change my priority to high. It's pretty important to edit tasks, so we should get that done. And I can maybe... So you can very quickly change tasks. Or you can even switch into full edit mode where you have access to all fields all the time. So I'm going to ask Mick to implement this one.
So you're delegating to Mick.
Yep.
Cool.
He's good at tasks. Okay, second, we have a built-in wiki that's powered by Mylan wiki text. So it's a multi-wiki or multi-markup language wiki. But from the web UI, it's just super simple. It's just a title, some markup, and quick access controls, because you don't need too much more than that here. So you edit with the markup language, you see it displayed immediately. So source control, I've got two Git repositories set up for this project. I can see their names, I can see the URLs I would use to connect to them, and I can see their commits. These two don't have any yet because we haven't done anything. We'll get back to that later. And then provisioned for you, as soon as you've created a project, is your own Hudson instance. So you have your own full build server. You can set up all your builds however you want to set them up. You can schedule them to run nightly. You can have them pull your Git repositories. They can pull external Git repositories. You can build ADF jobs if that's what you want to do. You can have Maven-based Java builds if that's what you want to do. You can run Ant tasks if that's what you want to do. This is a full Hudson build server. When you provision a project, you get a couple sample projects, sample build jobs that basically demonstrate how you can set up different types of builds. So let's switch quickly to the Eclipse tooling, and we can look at accessing all this functionality within Eclipse. So if we start with a clean Eclipse with nothing in it, in the Oracle Enterprise Pack for Eclipse, or OPI, will be included these tools where you get a dashboard for the Oracle Developer Cloud Service. And within this dashboard, you log in using the same credentials you'd use on the web to get to the web interface. And instantly, you can see all the projects you have access to. So you can see those same three projects, the one I just created, the one I created yesterday that we were looking at.
So even, if you've used Mylan before, which helps as much as it can automate your, the way that you bring in your Git projects, your issue trackers, all those tools within Eclipse. This is what Lucas would have just done by signing in to Eclipse with his credentials. It takes like multiple hours usually to get your workspace set up properly. With this, all of this information is now at your fingertips. It's all hosted in the Oracle Developer Cloud Service. You just sign in, and you can now think of your IDE or Eclipse IDE as this rich client for that cloud service.
So if I haven't done anything yet, probably the first thing I want to do is connect my task list and find my tasks. So from this dashboard, there are a number of wizards built in that will help automate all of these connection processes for you. So I'm just going to use a predefined search. I just want to see all tasks in this project. So, oh look, there's my two tasks already. So notice I didn't have to sign in again. I didn't put my credentials in anywhere again. All I had to do was, say what I was interested in. So in my Mylan task list, I already have these two tasks. I have two incomings, and I can just open them. So I have a full-featured Mylan task editor. So I can see all the attributes of these tasks. This one's in the tools product, and maybe I actually want to put that on a release so it gets scheduled. And because Mick is, well, maybe Clint should do this one. Split up the work.
So it's the same functionality you have in the browser with, basically a mile enrich client. It's all available to you offline, since mile caches everything offline. And, as you'll see later in the architecture, it's actually both the browser and the Eclipse Search client, they're using the same REST APIs to talk to the service over here. So you just have two kinds of clients, one running in your browser, one in your Eclipse IDE, both hosted, both with their data hosted.
So next thing I might want to do is share some code or import some code from the existing Git repositories within that project. So when you create a project, you get one Git repository created for you for free. It's just got the same name as the project. You can, of course, add as many Git repositories as you need to support your project. Maybe you want to break up your code into multiple repositories, you have major components, etc. In this case, I want to clone a Git repository, and then I want to share one of the projects that I have in my workspace. So this is just a quick sample app. So I can see here that I have two Git repositories for this project, and for each one of them, I have access under two different protocols. So I can choose how I want to set this up. So I'm going to choose this one. So what this has done is has cloned the Git repository onto my machine, has shared this project with that Git repository, and now it's all set up. I can make a commit. So now, maybe actually I'm going to take this task back, because I want to work on it later. And let's just push this before we do anything else.
And so the moment this push happens, what you often see with sort of these demos that are set up on a new hosted offering, a lot of that is just happening on your browser. This gives you've got the code in your IDE today for the project that you might want to try out, pushing to the Oracle Developer Cloud Service. So this, again, all that code's in your IDE with 3 or 4 clicks that are basically going through eGit and Eclipse. You've now got all that code hosted.
So I just pushed some code. I have a build server out there. I want my build server to build my code. So when you first create a project, you get those sample builds set up, and if I have them set up right, it will pick up the code change I just made and pushed. So what I'm doing here is running through the monitor builds wizard from the dashboard. It's filled out all my credentials automatically for me. All I have to do is select the build jobs on the server that I'm interested in. And all of a sudden I can see that I have a build server for this project titled New Project, and it had these 2 builds, and it's updated their status for me in the IDE. Oops. So this is the Eclipse Hudson integration. And so you can see all kinds of things about your build server. You can see which builds have run recently. If there were JUnit tests run, you can see all the results here. You can even pull in the full console from the build run directly into Eclipse if you need to inspect it.
And you've got, the functionality is basically tailored. So you've got in the web browser, you've got a lot more functionality for monitoring builds. You've got parts of the Hudson Web UI integrated, as Lucas showed you. Here you've got all the IDE-specific functionality. So if you're living in your Eclipse IDE, you've got, and later today we'll actually have a talk showing you how this has some of this functionality showing up in NetBeans as well, the Mylan NetBeans talk that we'll link at the end. You've got everything that you need to see as a developer. You just made a build fail. You'll get that pop-up notification in your OS. You can click into the builds view, see the whole failure of unit tests, and rather than having them stuck in the browser and copying and pasting test failures, it's just one click to bring all those failures into your JUnit view in Eclipse and run them in Eclipse as a second click. So you're getting, a lot of the stuff that we're seeing richer and richer experiences in the web browser for development. A lot of what we do in terms of running and debugging unit tests and writing code is still in the IDE. So we're just bridging these 2 worlds through this, again, through the web services being hosted in the Oracle Developer Cloud Service.
And Mick, I got started with all this by just downloading the IDE and getting started on it and signed up on the developer cloud service. I didn't install anything else locally. Source code is in the cloud. Hudson is in the cloud. Bug system is in the cloud.
Everything, exactly, yeah. So if you're ramping up a new project, it's just all there. And again, this easy path from taking the source code that you have and pushing it to the cloud.
So for every project as well, so I've just clicked on View Project Dashboard. For every project within Eclipse, you get an Eclipse-based project dashboard as well. You can see it's similar to the web dashboard. You can see all the builds, similar graphs, and activity stream. So you can see some of my activity here. You know, today I committed, and oh, look, the sample Maven build ran. So we should just be able to click on that even. Okay, so it looks like it succeeded and actually built a war. So that's good. So what's happened here is Hudson was set up to pull, so we can just look at the config even. Hudson was set up to pull that Git repository on the master branch every minute, and then just run a Maven build. So this view for you would update by default every few minutes. You can set it to whatever you want. If you hadn't flipped back to the web, you would just get this toaster notification that says, hey, your build succeeded. At that point, you know, you can do whatever you want. Maybe you want to deploy. Maybe you want to make another change. So let's try making another change first. So actually I want to work on this task that I assigned to myself. So let's just call it assigned, so other team members know not to work on it. Then I'm going to activate it. So activating a task instantly focuses your workspace and lets you filter any view that you want to filter down just to the current context of the task you're working on. And this is all part of the Multitenant Framework. So I'm going to change anything, really. It doesn't have to be substantial. So once I've got 1 or 2 files open, I can filter my package explorer. I'm only looking at what I'm interested in. I don't need to have any other overload. We'll just make a trivial change. So once I'm happy with my work, I can go and commit. And now, because I have this task active, I basically get a free commit message. Mylin and eGit coordinate together, and they look at the current task that you have active and the change set that you're working on, and it fills out a commit message. And you can set these up based on any template you want. So the template I'm using says, you know, put the task and its identifier in, and then the summary of the task, and then a pointer to the task URL. So I'm happy with that, so I'll just use that.
There's, you know, some of the original Multitenant functionality, but what's interesting here in terms of this linking that Multitenant does between tools, what's interesting now is it works for Git. So display link tasks and commit messages, and what's really cool is the way that you'll see in the web UI on the developer cloud service, the way it's exploited. The fact that everything gets linked in your activity streams, for example. All the commits and source code and activities automatically linked because we're able to extract that additional activity in the IDE from the developer's activity, just from Lucas activating his task to get a context.
So let's go see what I've been doing, I guess. So in this activity stream, I can see that I committed something, and here's the message. And I had set this task to assigned. Okay, so let's go look at the task again. So here what I can see is it's moved to assigned. That's not very interesting, but I can also see the commit I just made. So because these are all hosted together, all the project services know about each other. As soon as I push my commit with the right message, I can now have full traceability from that task to all the commits that implement changes for that task. And I can look at the full commit on the web as well. So some people prefer to use Git on the web and look at diffs this way, maybe if they just want to look at something quick. Other people prefer to use the full eGit tooling, where they can look at the full history in eGit or something like that. So I'm done my task. I'm going to resolve that as fixed. Submit it. And I think I pushed source code, so I should have another build running at some point. Let's go look on the web. Yep. So because my job is set up to pull for changes to my repositories, it just kicks off a build whenever something happens. So this is pending. We have to wait we don't have to wait long. It's running now.
And the same way your IDE just always, a modern IDE just always running your builds and compiling your system for you, your build plans are now running automatically, using what's a very large infrastructure for those builds. So we'll talk about later how the Hudson build farm works here, but you're basically getting resources from the Oracle Developer Cloud Service for running these potentially very, very large builds, all hosted, and all via Hudson. And the limitations that we kind of see in the IDE start to go away when you've got access to those kinds of resources for your project.
So while it is building up, so if I am just starting on a new project, I can sign up for the Developer Cloud Service, all this system is set up for me, and I can get started right away. If I'm already using existing tooling, and I have a source control that I am using maybe from GitHub, maybe from somewhere else, I can migrate them into Oracle Cloud. If it's GitHub, I don't need to move it. If I'm using a bug system like Bugzilla, I can migrate them into the cloud-based issue repository. If I'm using Wiki, we support multiple Wiki formats, so I can just migrate them into the cloud and then continue to use all the functionality of the Developer Cloud Service. But either way, like you said, the powerful systems are available to build and all that stuff, and it scales up just because it's in Oracle Cloud. So if the project you're working on catches fire and you now need to have more developers work on it, you can just scale up using the elasticity of the Oracle Cloud.
Yeah, exactly. And it's all, it's again back to that best of both worlds, right? Access to all that infrastructure, and then none of that annoying manual configuration that you have to do. The moment Lucas pushed the change, the build just kicks off. So once you've got this kind of infrastructure, once it's all integrated, so it's not, you're not setting up 5 servers, it's one turnkey setup with all the services you need for your project. This automation, it's been possible for this automation that you're seeing here to be layered in. Where again, our whole goal of you not doing all that manual busy work is gone, while you're still getting to use these tools that that are so popular now. So
let's do this.
So we'll switch over and talk a little bit about the architecture, and we'll make sure to leave some time for questions after as well, and then do one more demo at the end of basically closing the loop and going to that deployment destination. But quickly, what you're seeing here is that there's a Code to Cloud hub. There's a notion of team identity that's pluggable. These are those open source components, and everything you're seeing here with the Oracle Developer Cloud Service is built on some of these open source components. You're seeing Hudson again, Mylan, Git and Garrett, and so on, with all of this value added on top. As I mentioned, the connectivity, you've got 3 modes of connectivity to it. So you've got and the cool thing is they go through the same abstractions. Through those same task abstractions, through the same change abstractions. So when Lucas showed you the activity history, that's a unified activity history over everything that's going on in the underlying services. And we'll talk later how you can actually extend that, say bring in other application lifecycle management tools. You're getting a bunch of interoperability out of the box. As Gangadhar mentioned, you can actually even use GitHub repositories out of the box, since GitHub has been so popular as a hosting destination. So you can paste in Confluence syntax into the wiki system. It actually understands Confluence, because what Mylan's done is it's created all these abstractions that work for multiple ALM tools, because there's such a wide variety of those. But yeah, the key thing is here, you've got a common API, you've got REST tasks from the IDE, basically the very similar access through the browser, through Google Web Toolkit, and of course the native clients. And it's all transparent. The fact that there's this huge farm running your servers, all of the public cloud infrastructure running it, it's still very much transparent to your native client, which thinks it's talking to a Git server, even though you've got high availability behind the scenes, and the kinds of things that are just very difficult to set up with your own Git instances if you've tried that. All those services that you saw, and then we'll get back to the deployment. Anything to add in this, Lucas?
No.
Tasks and Wiki services. So do you want to speak to those just a little bit?
Sure.
Some interesting architecture there.
So we use two major types of architecture to handle load. So the first one is just a very traditional web application, stateless web application where you can scale horizontally. So Nick was talking about the hub. All traffic is authorized and authenticated and proxied through the hub, and then is passed to one of the underlying services. So in this diagram, this demonstrates the architecture of the task service. The traffic is passed from the hub to a load balancer. This could be a virtual IP. And then depending on the amount of traffic in the build or in the instance, you can scale the number of task servers you have, and those all talk to a shared database for persistence. So that's multi-tenant. All the data for the task service is in the same database, but the data for each project is in its own schema, so it's fully separated from each project. The second major approach is to, and this is used for Git services and Maven services, is to again proxy at the hub, but then pass the data to a specific Git server associated to that project. We do this for a few services because there's heavy disk I/O to actually support the service. So Git is traditionally serialized down to disk. And so in this case, there's affinity between a specific project and a specific Git server. So you see that here in this diagram.
And it's enterprise-grade Oracle database sitting underneath the covers for all the database access required for the developer cloud service.
Just quickly on the tenancy, Lucas.
Yeah. So to implement this, we actually created an interesting multi-tenancy framework. When you're dealing with multi-tenancy in an application, there's two common problems you have to deal with. One is how to identify the tenant, and then two, what to do once you know who the tenant is. So first, when I'm processing a web request, I want to set up some context for the tenancy, who the tenant is, and then some information about them, just like you would with a user context or a session. So this framework supports initially two strategies for identifying tenants. First is a fragment in the URL. Another common strategy that we support is adding a custom HTTP header to the request. And this is extensible, so you could have many strategies for identifying your tenants. Second, you want to figure out how to isolate tenants from each other within your data. A common approach is to use a single schema with data for many tenants in it. And for that, you might use a column and a tenant data key. In the method we're using, which I described earlier, we actually have a different schema for every tenant. And so that's the second approach, where we use what we call a data switching data source. So a request comes in, and it reaches the task app server, and we actually switch schemas dynamically and then run all of our code, which is written entirely in a single tenanted fashion. So you write your code and your services in a way where, as a developer and a testing team, you only have to think about logic for a single tenant, and we abstract away the tenancy to the request processing layer.
So, the neat thing is, I think some of the technologies that you saw at this conference and discussed at Open World is that it's now going to be much easier for you to port your existing applications without worrying about most of the stuff. Multi-tenanting existing Java applications is a total pain. We've, in terms of providing sort of scalable services, we've had to do it in a few different places. And what we've done previously is, and we actually learned the pain of what it takes to multi-tenant these things this way as well, so if you can avoid it, do it. But just as with Mylan, we've open sourced our common glue components. What TaskTop works on is the glue that wires together various ALM servers and collaboration services and so on. We've open sourced those in Mylan with our common models. What we've open sourced here is some of the server-side infrastructure components, some of the server-side glue needed to put together these various ALM services, connect them to various vendors' ALM tools, our partners' ALM tools. So there's this code2cloud.org project where some of this infrastructure is now open sourced, and that includes some of the tenancy frameworks as well. A little bit on the Hudson build pool, because again, with all of these things, they have very different strategies for providing you the sort of scalability and availability that you need and leveraging the resources of the Oracle Cloud in an efficient manner.
So you saw when I pushed code, it built, within 30 seconds, a build was started. And that's because there's actually a pool of build executors behind the scenes. This pool is shared across all projects. And when your project needs an executor, it just grabs one from the pool. So what's cool about this is you can have a dynamically sized pool, and the developer cloud service will have a dynamically sized pool of executors that scales up and down as demand waxes and wanes.
And again, right now you're probably managing this manually, or someone else in your organization is, and adding and removing servers and so on. The economics work much better if you've got this shared across many servers. And across many projects and across many organizations in the end.
So what's cool about that is, if you were running this yourself, you could size it to your budget or hardware. If you're going to use the hosted developer cloud service, they worry about sizing it to their budget and hardware. And the goal for you is that you just have no wait times. You ask for a build executor, you get a build executor, you run your build.
Yeah, and it's just very key thing that's happening in this transformation is that we, in terms of the big picture, we need to move to a world where we're worrying less about wiring together the stacks that drive our application development, the ALM tools, and actually just building the apps. And this is exactly some of the core concepts that we've abstracted away here that, that can be run on this highly efficient cloud infrastructure.
So just quickly, the architecture. When you're Hudson master, which is what coordinates all your builds and does the polling of your Git repository and shows you the web UI, when it detects that it needs to run a build, it asks the hub for a new build slave. The hub then looks at the slave pool and says, A, do I have any? Maybe I need to wait. But if I don't, I should provision a new one. And then it authorizes a slave for the master. That master then gets a lease for a build slave. And then and the hub tells the master about it, and then the master goes and runs the build on that slave. When the build is finished, the master gives the slave back, turns over its lease, and the hub then cleans the slave and puts it back in the pool as an available build executor.
So just to wrap up with the components that you're seeing here, you've got these open source pieces. They're extensible. There's an extensibility layer on top of it. You can use Mylan's SDKs. You can use REST APIs. And there's other services like single sign-on. TaskStop is providing bridges to other ALM tools because you've probably got other ALM tools within your organization. You might be using Quality Center for testing. If you've got a large-scale Java shop, you might be using IBM Rational Team Concert to orchestrate across all of that, but you want some of these services and deployment capabilities you're about to see. So the TaskStop sync bridges for that, gives you adapters for open protocols such as OSLC, which we'll actually be talking about tomorrow as well in the session tomorrow afternoon. So how you can extend this, how this can be integrated with other efforts like the Oracle Team Productivity Center and so on. So the key thing here is that this is designed to fit into your ALM ecosystem now, not as an afterthought. And there are REST APIs, for example, that you can start using to query code to cloud as well, similar to the way the native clients do. But right now, let's skip over to the best part, which is actually connecting this to the running application.
So, all right. So I have my distributed development team. They started using the developer cloud service, and they built this, let's say, a Java EE app or an ADF app or a VAR like Lucas showed earlier. Now I want to run it in the cloud. What do I need to do? Do I need to manually upload it into the Java cloud service and deploy it? Or is there something seamless that I can do? The good news is,
Actually, we'll do this one.
okay. The good news is, because the developer cloud service and the Java cloud service are both running in Oracle Cloud, they are integrated with each other. There is this concept in Oracle Cloud called association, where if you have multiple cloud services from Oracle, you can associate them with each other so that they know about each other and do a handshake and communicate. And that is what we're going to demonstrate now, where we're going to start a new deployment. So now the scenario is Lucas and Clint and Mick all developed this application. There is a VAR being built in the continuous integration build system in Hudson in the cloud. Now all I want to do is to deploy it to the Java Cloud Service. Now, in the deployment screen, I already see that my target Java service is selected because the Java service and the developer service are associated with each other. I can either choose to do a manual deployment or an automatic continuous deployment. If it's a test system, I probably want to choose a automatic continuous deployment. And if it's a production system, I probably want to do manual after it passes some tests and I get the approvals. Now, I just give it a name. Did I turn on my mic? Okay. I just give it a name and say save and deploy. Now the application archive, VAR in this case, is getting transmitted directly from the developer cloud service to the Java cloud service in the cloud directly without any downloads, and it got deployed into the Java cloud service. I can look at the log here. I can go to the Java Cloud Service Enterprise Manager UI to convince myself that the application is indeed deployed. And I do see that the customer orders application is indeed deployed. So it's as simple as that in terms of either a manual, individual deployment or a continuous deployment to integrate the two pieces we have in the cloud, the development environment with the developer service and the runtime environment with the Java Cloud Service. Now the developer cloud service is in preview right now. And so if any of you are interested in participating in the preview, please meet us after the talk, or you can come to the Oracle Cloud Developer Service demo booth. All the Oracle Cloud demo booths are in Moscone North upper lobby. And there is a booth for the Developer Cloud Service where you can see more details and sign up for the preview.
All right, great. So just quickly to wrap up, again, out of the box, TaskTop Sync, which is the sort of ALM interoperability, the leading ALM interoperability tool with support for all these various tools, which you might already be doing, supports the Oracle Developer Cloud Service. You're using a different issue tracker. You're using one of those enterprise ALM tools. Those can be connected in real time to the Oracle Developer Cloud Service out of the box. So again, a key thing. And the main thing that we want to emphasize here is that you're getting all the turnkey benefits of those lightweight tools, all the benefits of the Oracle Cloud in this package where all the details, all the hosting, all the provisioning, all the connectivity are taken care of for you, and the integration is there, so you can start using it from day one. Whether it's to take an existing project, push it straight into this, take your GitHub projects, or integrate it with one of these tools. Say if you want to add agile planning as a layer over top of what you've got, the activity that you've got happening here, you pick one of those agile tools. And you get to this point of basically this continuous deployment where going from your IDE to your deployment destination is totally automated, and the tools and the steps on the way are just a normal part of your process, whether you're in the IDE, you're working in the web browser. So for more, we've got links over here. So the JDeveloper ADF community, you've got links right there. We've got a few more talks left. So there's going to be a talk on Mylan and NetBeans. You'll see some of these concepts that Lucas showed in the IDE, how they're now materializing in the NetBeans IDE. And then there's a talk tomorrow on linking the application lifecycle. So kind of a bigger picture talk on how we can connect up these things to the application lifecycle through open standards like this OSLC, so that we can get traceability in the whole across these various tools, and that's tomorrow at 4:30 p.m. So with that, I think we'll wrap up, and we have some time for questions. Thank you. Any questions? Yeah?
Absolutely. I'll take that. So Java is the one that resonates more, and it's simpler to visualize if it's a Java EE app. But typically, you're building a Java EE app, and it has database dependencies, so you can push it. Then what happens is the Java service and the database service will have association between each other, so that the database is accessible as a data source from the Java cloud service. and you can push both the schema into the database cloud service and the application artifacts into the Java cloud service. There is also, you can build just the database applications using tooling like Apex in Oracle, and you could just publish them into the database cloud service. So all possibilities, all of those permutations and combinations possibilities are possible through the association between each other.
Yep.
What is that?
Not this. An on-premise version of this? No. But you can download so the code to cloud open source components you can download and stand those up on-premise. But oh, okay. So yeah.
So in other Oracle Open World sessions about the cloud, we'll talk about the private cloud offerings from Oracle, and the private cloud offerings from Oracle will include the developer cloud service as part of that. So I think the point there is private clouds are the same as Oracle Cloud that run in an environment outside of our data center, that is in your data center, right? So everything else remains the same.
Question over there?
Let's say I use developer cloud service to develop my application, but I want to deploy it on my open service. We have deployment servers locally and restricted data from one outside. I have the idea. Can you do that so that you can deploy it on the local, like I have mine?
Do you want to take that?
Yeah, absolutely. So there's a couple options. You can go to your Hudson builds and you can download the, say, war artifact or EAR or whatever you've built, and then manually deploy that. Or you can set up a job within your Hudson instance and some automation to push that artifact out to your server, or even the inverse, where you use the REST APIs that are available from the developer cloud service and programmatically, maybe through a deployment job running on some other server, pull down that artifact and then deploy it. So you can use many pieces of this service independently or together, and pick and choose which ones you want to use.
Or you can run the application in Oracle Cloud.
Yeah.
And yeah, and if you use them independently, again, you're getting, you're then managing those aspects on your own, because the beauty of that automation is it can be done when it's all sort of hosted within the reach of that of the cloud destination. Yeah?
That was part of the Eclipse. What is it? Options? Also, for which developer version will it be available?
Yeah. So we have integrations with all three IDEs, the JDeveloper, Eclipse, and NetBeans. The JDeveloper integration would be available in the 11.1.1.6 version, which is our JDeveloper version that works with Oracle Public Cloud. Right? The same version that works with the Java Cloud Service and the Database Cloud Service will also work with the Developer Cloud Service. And NetBeans will have the next release of NetBeans that kind of goes with the Developer Cloud GA is the one that will support the functionality.
Yep.
So, two questions. What's the pricing and cost benefit? And the other is, what if you want to move to another cloud provider? What sort of help is given, and what's the interoperability?
Am I on? Okay. So I'll take them in the reverse order. In terms of migration, just like we talked about how you can migrate from another location to Oracle Developer Cloud Service earlier, Mika and I were talking about it. It's similar. So you can download the source code and you can move it. You can download the bug system from the schema. So basically all of the Oracle Cloud options, all of the Oracle Cloud Services, not just the Developer Cloud Service, have self-service control through which you also have an archive and download mechanisms. And those will be available here as well. And hence, if you heard Larry Ellison the other day or Thomas Kurian this morning, they talk about standards-based and open and no lock-in as the key facets of our platform as a service offerings, of which the Developer Cloud Service is part of. And to the first question, we're still working on the final pricing. As I said, we are in preview right now, and by the time we go GA, we'll figure out the pricing scheme. For preview, obviously, it's by invitation, and we're working with a few customers, and we still have a few slots that we can fit someone in if you're interested. And of course, preview is free.
Back there?
So if you're running tools that are can be uploaded as artifacts or found as Maven artifacts or something like that, that's sort of quick and easy and totally possible. So you have a full Hudson build server. You can run a number of plugins on that build server as well. The only real limitation is that it's from a set of plugins that's been adapted to work in this environment. So out of the gate, obviously there won't be support for every Hudson plugin that exists, but the premise is that over time and based on demand, each of the popular plugins would be supported. So maybe there's a Hudson Selenium integration plugin that you want to use or something.
Yep. Oh, wait, by the way, you can come to the booth. So you already pointed people at the booth in Moscone. We've also can do some more demos at the TaskTop booth on the floor at Java 1 here. Booth 5428 or something like that. 08, yeah. But go ahead. We still have a couple more minutes.
Familiar with Git and familiar with many of my clients with the subversion about it. Do they have to move to using Git, or can they stay with subversion? Many of them are still struggling with this environment, so in many cases they're not so happy to move again.
Yeah, I mean, this is an interesting question. I think it'll be an interesting sort of feedback loop. Git was selected intentionally because so many of the new a lot of companies are leapfrogging Subversion and their move, or now sort of at the limit of what Subversion could offer them. So it's definitely possible to integrate Subversion into these services. And I think it'll just be a matter of time. Like just the speed of the move to Git, just like that's the speed of the migration away from onto Hudson, onto the more modern build system from cruise control was just so fast. That's kind of been we've not worked on it yet.
You covered most of it. Currently, Git is the source control repository. There's nothing preventing us from adding other options going forward, but there are no concrete plans to do that between preview and GA at this point.
Basically, it's for the clients. The developers are working with it, and they are now getting used to it.
Oh yeah, I mean, you've got developers all over the place working in Git and checking into other SCMs, right? Also, Git in itself has a variety of problems that have to do with its complexity, right? How challenging it is to set up, and I think it's pretty important that a bunch of those has been addressed in the automation that's been provided here, right? The sign-on, the access control. Access control is a pain in Git, and people set up Garrett, and it's a manual mess. Some of those key adoption challenges of Git have been addressed by the Oracle Developer Cloud Service. So again, I think you can try it out and I guess check into Subversion if you need to. But, all right, thank you, everyone. Oh, yeah, go ahead, Steve.
So you showed one slide where you have to cloud specified extensibility.
Yeah.
SSO, violence. So where does that actually sit? Is that including cloud, or is that a Oracle?
The APIs are in Code to Cloud. So the REST APIs, they are. The plugins for the SSO, but the identity is coming from the Oracle services. So it doesn't, that the sort of large-scale identity system is not in it.
So you could plug into your SSO system, basically. Maybe you want to just plug into LDAP or some other SSO system you have in-house.
Yeah. All right. Thank you. And yeah, pop by the booth or stick around for more questions and answers. Thanks.
Thank you.